happens to be occurring, I just want to bring up. Last night I posted a kind of a quick introduction to SPSS and a review of the functions of beginning functions of SPSS, and the different windows that you might work with and so on. Just again, so you see it while it's starting up. The startup page usually comes up something like this. You can open a new data set. You can open recent files. You can open some existing or convert existing files from other formats. Many people don't use this window. The only reason I keep it up is so that I don't confuse students who may have just installed SPSS. But if you don't like this window, you can just click Don't Show This dialog in the future on startup, and it won't start up with this window. It'll just start up simply with the data page, an empty data set for SPSS. Okay, the other thing about SPSS is, although it looks like a spreadsheet, we know it isn't. We know that each row represents a subject, each column represents a variable, and in the data view, we actually see individual subjects, their data, their gender, their age, their weight, so on and so forth. In the variable view, we see each row represents the technical details of each variable that's on each column or each variable that's on the data view. Okay, and that's going to include, for instance, the name of the variable. Now, name of the variable's got to be letters and numbers only, no spaces, no special characters, and it's got to start with a letter. Can't start with a number. That's kind of limiting. So because it's kind of limiting, we have a little box over here where we can put in a label for it. So this could be something like BP, and the label could be blood pressure of students in EOHS or something like that. It could be more descriptive, and the label is what prints out in most cases instead of the variable name, so that you get much more descriptive and understandable graphs and tables and so on and so forth. The type is usually numeric or string, which is text. Usually that pretty much sets itself. That's really not the type of variable. It's just the kind of format that you put it in. Like a 1 or a 2 could represent, this would be numeric, like a 1 or a 2, but it could represent a nominal variable or a categorical variable, like gender could be represented by 0 and 1 or 1 and 2. The width, just how many spaces you want to allot to it. If it has any decimal places, how many decimals. Now, I'm going to skip values for a second. You can define what missing values might look like. Like you might want to say that 99 represents a missing value, or 101, or whatever you want to define it as. So the SPSS will see it as a missing value, and you can operate on it if you want. For the most part, we don't have to worry about that. If they're really missing values, SPSS will ignore them for the most part. This again is just the display, how many columns to display, how to align them, whether align them left, right, or centered. And here, when we get to measurement, we get to something that becomes important again. And in here is where we tell SPSS what kind of variable that we're dealing with. Now, let me see. I want to actually put in some data here. I'm going to put in a number here. And I'm going to put in a letter here. Okay, whoops. I'm going to go back to variable view. So you get assigned, automatically assigned a variable. When I put the letter in, it automatically figured, oh, that must be nominal, right? Well, it could be nominal, it may not be nominal. Okay. When I put in a number, it said to me, oh, gee, that must be one of 3 kinds of variables. Either nominal, because you might have a number might be a nominal variable, like for gender or something like that. Or it could be scalar, in other words, say blood pressure, and the number on a scale, a numerical variable, discrete or continuous, doesn't matter. Or it could be ordinal, where it could be something that represents a scale that doesn't have a definite value, but relative to each of the values the subject might have is different in a relative way. For instance, fair, good, excellent, or something like that, or a pain scale or something of that nature. So in this case, it was a numerical variable, which, I was talking about blood pressure. So we want to make sure SPSS will take a shot at defining the type of variable. Whoops, I'm going to make that a scale. It will define the type of variable, attempt to define it anyway, but you have to make sure occasionally, you have to glance over it and make sure that it got it right, because it will get it wrong occasionally. So now, the column that I skipped over, values, okay, that's really only important when we're talking about nominal values, nominal variables, like this variable. I'm gonna call this variable gender. Okay, so in the values, if I click in here once, see a little box appears with some dots. If I click again, a box comes up where I can define what the variables mean. For instance, I can tell it that the value 1 represents male. I can add that. Now, if we're talking about ethnicity, I might put 3 represents Hispanic, etc. Obviously, I'm just making these up. You know, you wouldn't have these two together, but you could use it for ethnicity, you could use it for gender, you could use it for any nominal variable. But this is where you tell SPSS what those different values mean. So I'm going to go ahead and I'm going to minimize this, and I'm going to go ahead and start looking at the homeworks that we had and run through them as quickly as we can. And maybe if you have some questions or something like that, you can chop into the chat there and ask me about it. I may change my numbers for some of the assignments, because I want to maybe give you a different look at them. Excuse me, cough. Okay, so let's see. So let's take a look at this. First of all, I told you in most cases how many of these variables I would expect that would meet the criteria that I given. So I gave you that hint, because I noticed a lot of people, once they got 1 or 2, might stop looking when there might be more. Which are nominal categorical variables here? Well, we know country of origin is. Number of siblings? No, that's a number. Do you smoke? That's a yes or a no, so that's a nominal variable. How many cups of coffee do you drink in the morning? Nope. What's your blood pressure? How do you rate that? If you want to go through these quickly, how many siblings do you have? That's a discrete numerical variable, right? That's discrete. How many cups of coffee did you drink this week? That's discrete. That's a whole number. What's your blood pressure? That's a scalar or numerical variable, okay, because that operates on a whole scale. How would you rate the MPH program? That it's going to be excuse me, ordinal variable. Okay, so question number 2, which of the following discrete numerical variables? Okay, discrete. Okay, let's see, what's the country of origin? No, that's nominal. How many siblings do you have? Ah, there we go. That's a discrete numerical variable. You smoke, again, nominal. How many whole cups of coffee do you drink today? That's a discrete numerical variable. A scalar for blood pressure. How would you rate the MPH? Again, same deal. What's the average number of coffees you drink per week? Well, where before we were talking about, like 1 or 2 or 3 or 5 cups of coffee per day, now we're talking about an average. Now, if you take an average, it could be 3.2, could be 4.9, could be 2.75. So that now turns into a numerical variable. Just think about what kind of number it could possibly be. What's blood lead level? That's a numerical variable. You smoke. Again, a nominal variable, yes or no. How many cups of coffee drink this week? Again, that's a discrete numerical variable. Blood pressure, so on and so forth. Okay, which of the following ordinal variables? Let's see. What ordinal variables do we have here? On a scale of 1 to 10, what level of pain are you in? Well, that's an ordinal variable, right? One person's 3 might be different from another person's 3. But for that person, we know that 4 is greater than 3. We don't know how much greater, but we know it's greater than. So we know the order, but we don't know the actual value. How many cups of coffee, so on and so forth. How would you rate the MPH program? Again, that's an ordinal variable. Okay. Now, referring to the charts, we asked you a number of questions about these charts. I'm going to use a different, actually the chart was a histogram. In fact, a histogram. I'm going to open up a different histogram, and we'll take a look at that right now. Let's see where I put it. I think I've lost track of it. Let me find it now. Oh, here we go. Okay, let's say that this represents a series of scores, test scores. Okay, now if I asked you, excuse me, if I asked you how many people scored under 70 on this test, we know the height of the bar of a histogram represents the frequency, the number of people, number of subjects, number of occurrences that have taken place. So in this case, it looks to me like we have three people were between 60 and 65, three people were between 65 and 70. If I ask you how many people were below 70, that would look like it's going to be 6 individuals. Okay, so now if I ask you how many people took the test, it would be 3, 6, 8, that's going to be 14, 24, 24, 29, and 3 is 31. So we have 31 people took the test. If I told you, out of those 31 people, if I asked you if I told you that the passing score on this test was 75, and I asked you what percentage of people passed this test, you would then say, okay, well, this 31 people took the test. How many people passed? Well, we have 10, we have 5, that's 15, and we have 2, that's 17. So out of the 31 people, right? Whoops, excuse me. 17 people out of the 31 people passed the test. Okay, no surprises so far. Everybody's comfortable with this? I'd report that answer as a number between 0 and 1, the percentage, so proportion, which would be 0.548 or 0.55 would be good enough. 31 total, yeah, that's the way. Unless I got it wrong, you guys can count it behind me and make sure that I'm right. Okay, so now I could ask you a variety of things. If I ask you where is the median value, give me an estimate of the median value. Well, let's see. The middle person would be the 16th person, right? So I could count up 16 people from the left, or count down 16 people from the right, and I would be in the area of the median value, the middle person. So let's see, 2, 3, 6. In this bar, I'm up to the 14th, 6 and 8. I'm up to the 14th person. I haven't gotten to the 16th person yet. That 16th person is in this bar between 75 and 80, right? But since I'm only up to the 14th, only 2 more people that have a high scores, probably closer to the 75 than he is the 80, but at least I know that the median is between 75 and 80. Median's going to be in here. Okay, so we might ask you something like that. I asked you percentiles before. I might stay away from that. Maybe, I might ask you if I asked you what the lower percentile, the 25th percentile would be. Well, that would be the person that would be the 25th percent highest score. So out of 30, let's see, the middle score is going to be, we said 16. So the lowest quarter is going to be somewhere around the 8th score, somewhere, right? So the 8th score is going to be in this bar over here. Here's the first 3 people, lowest 3 scores, next lowest 3 scores. So the 25th percentile is going to be between 75 and 79 if we were to ask you that. Okay, so that's basically how this works. I know some people had every semester people have trouble interpreting this. And I think it's just because it's a new way of kind of looking for things, for looking at graphical display of data for a lot of people. But that shouldn't be too complicated. That really shouldn't scare you that much, as long as you don't get. Now, there is one other thing. I might ask you something that's a conditional probability. For instance, I mentioned that the passing score was 75, right? I might ask you something like, given that a student passed the test, what's the probability that he got over 85? Okay, so given that he's passed the test, so we know we're only dealing with the people that are over 75, the ones that passed the test. So that's 10 and 5 is 15, that's 17 people. What's the probability that he got over 5? Well, only 2 people got over 75, over 85. So that would be 2 divided by 17. Okay, and that's a conditional probability. Given that this condition is satisfied, that I'm only looking at the students that pass the test, with a 75 or higher. What's the probability that someone in that group got over 85? Okay, so hopefully you can look back at this if you need to. So let's go on. Okay, let's stay away from presidents for now. Okay, the next thing I asked you to do is using the data provided in descriptive statistics .xls, calculate the mean, median, mode, standard deviation, minimum, maximum, so on and so forth. Okay, so I'm going to open up descriptive statistics. Was there an underscore there? Oops. Here we go. Here's a version of it right here, I think. See if this one opens up. Oh, I got the same problem there. Show me in Finder. Here we go. Let's open this up. Okay, so I may ask you a number of things here. One is I won't ask you to go through that whole thing with calculating the differences and calculating the sum of squares and so on and so forth. You can actually use the Excel the Excel functions, built-in functions to do this. For instance, mean equals average, parentheses, and just highlight or give it a range of the numbers that you want to find the mean of. The median is equal to, the median is the variable. Now, if I type in median, you'll notice that it narrows it down. There is a function called median. When I hit the parentheses, it shows me what it needs next. If you want the median, you need to put in the numbers that you want the median of. So I want A1 through A10. Okay, and the mode. Whoops, got the equal sign, equal, M-O-D-E, parentheses. Okay, don't worry about it if there's multiple choices of mode. We're going to use the simplest one. Okay, and I'll highlight this. And it happens that 73 is the number that occurs most frequently. Not all, you don't always get a clean mode, but sometimes you do. Minimum, there's a function called min. Notice that min, or as soon as I type the NIN, there's no minimum, but there's min, parentheses, and again. Okay, the maximum, parentheses. Okay, you can go through, you can list these functions on f of x. You can go into the help function in Excel if you're curious about them. And you can also Google some instructions on Excel to see a list of the possible functions that you have. Now, the range is the maximum value, which is 75, minus the minimum value. It's a measure of the spread of the data, which is 10. Okay, and the variance is also a measure of the spread of the data. We saw how to calculate that in class. Parentheses. Okay, now I'm going to ask it to find the variance of all these numbers, and the variance is 13.2. Now I know also the variance is also equal to the standard deviation is equal to the square root of the variance. So I could use the square root function, SQRT equals SQRT, click into variance, so it knows it's in C20, hit enter, and it tells me it's 3.64. I could also use the standard deviation function. TDEV. There we go. So you've got all sorts of various versions of it, but you can just use the simplest, parentheses, and just give it the list of numbers you want, standard deviation of. Okay, now the other thing, notice came out the same as finding the square root of the variance. Okay, so I don't see any questions coming up, so I'm going to just continue going along with what I did now. Now, the other thing I might ask is the interquartile range. Okay, and we know that that's the value between, that's the distance, kind of the range between the 25th percentile and the 75th percentile. Okay, and so I'm going to click in here and say the 25th percentile. How do I figure that out? Look, I'm going to type in an equal sign. Let me start to type in that command, see if something comes up. Well, in fact, there is a percentile rank, percentile, and there is a simple version of it. So I'm going to use that one. I hit parentheses. Next thing it comes up tells me it needs an array and it needs K. If I call up the help function at this stage, it's going to tell me, I can click on there and it'll open the help function. it's going to tell me that the array is actually a list of numbers, the values, right? Which is A1 to A10, comma. Now K represents the percentile, but it represents it described as a decimal number, 0.25. Okay, and if you put in 25, it won't work correctly. 0.25. Hit enter. The 25th percentile is 67. 25% of the scores are below 67. 75 of them are 75% above 67. Let's try 75th percentile. Equal parentheses, and now I'm going to do the same thing. The array, comma, and this time it's going to be 0.75. Okay, and so now the 25th percentile, 67, the 75th percentile is 73. The interquartile range is equal to 75th percentile minus the 25th percentile, or 6. Interestingly enough, we get a slightly different number in SPSS. It actually calculates it a little bit differently than Excel does, but close enough for our purposes, especially with this little bit of data. Okay, so that's basically what we have here. Now, I might ask you to copy this into a Word document, just highlight the whole thing, copy and paste, or I might ask you to save the file to the desktop and then upload it to Blackboard, or maybe just ask you to transfer the results that you get onto the exam, which is going to be run through Blackboard. Okay, so I'm going to get this out of the way. So we got that question out of the way. Okay, so question 8. Repeat the calculations that we did in the previous problem. In other words, the one we just did, and see if you get the same results. Well, I'm going to go into Excel again. I'm going to just copy these numbers. I can import. I'll probably give you the we've already gone through ways to import data from Excel into SPSS. I probably won't ask you to do that on test. I'll give you whatever file you need in both formats, most likely. But in this case, I'm going to just do the simplest way possible of importing a file into SPSS. I'm going to open a new data file, new empty data file. I'm going to click up. I'm in the variable view, right? I got to be in the data view to do this. Okay, I'm going to click in here. I'm just going to say paste. And I'm just going to paste those numbers in there. Notice it made up its own variable name. I don't care about that. I'm just going to do the math right now. So I have these 10 numbers imported into SPSS. I'm going to go into SPSS and I'm going to say analyze. And remember, the recorded session I did that I put up last night will give you a pretty good idea on the mechanics of SPSS in more detail than I'm doing it. Then I can have time to do it right now. Okay, let me just make sure we're still recording here. Yes, we are. Okay, so now I'm in SPSS. Now, in order to analyze this data, I would go, surprisingly enough, to the drop menu for Analyze. Click down on Analyze and I have this whole series of functions here. I can go into descriptive statistics, which is what I'm interested in. I have choices, frequencies. Now, frequency you would use mostly for nominal or categorical data. How many males, how many females? How many redheads? How many blondes? How many left-handers? How many right-handers? When you have categorical variables, you're interested in frequencies. If I use this for this variable and put in frequencies, I'm just going to get just going to spit back 10 numbers because it's almost none of these are the same number, right? So it doesn't make any sense to do descriptive statistics frequencies for numerical variables. You usually reserve that for nominal or categorical variables. When you want to count them up, when you want to make a bar side by, like bar chart where it's side by side, you have a bar for male, how many males, how many females, how many diabetics, how many non-diabetics, and so on. We're interested in descriptive statistics, something that describes a numerical variable. For instance, a variable such as blood pressure or blood sugar or blood lead levels and so on and so forth. Now, descriptive statistics gives you a limited amount of information. I'm going to run it so you can see it. Okay, there's the variable I'm interested in. I have to tell, very frequently you have many variables, so you have to tell SPSS which one you want to work with. And you can click into options, and it'll give you like options about what you would like to run. I want the variance. That's one of the things I know I asked for, right? And that's about it, I think, right? That's all that I recognize there that I had asked for. I'm going to click OK. SPSS opens an output window. This output window is completely separate from the data window and the data and variable window. Okay, if you save your data window and close this without saving it, you lose it. You won't have this window anymore. So here, this told me the minimum value, the maximum value. I could figure out the range if I really wanted to. The mean, the standard deviation. It doesn't tell me the median. It doesn't tell me the range automatically. It doesn't tell me the percentiles and so on and so forth, or the interquartile range. So a lot of stuff that this doesn't tell me. Well, if I go into analyze descriptive statistics and I bump it down one more, I can go into explore. And in explore, I have an extra couple of boxes. Well, the variable analysis, the numerical variable I want to analyze goes into the dependence list. Okay. Now we're going to look at factor list in the next problem. We're not worried about that right now. Statistics. Well, now it's just the only choice I have is to run descriptives. It decides what it's going to run. Okay. If I go into plots, I can ask it to do a histogram for me if I want to. Well, we didn't answer that on this problem, so I'm not going to bother. Display both statistics and plots, or just statistics, doesn't matter for us this time because we're only interested in the statistics anyway right now. So I'm going to click OK. And it's going to do the analysis. And notice now we have the mean, the median, the variance, standard deviation, minimum, maximum range, the interquartile range, and other statistics as well. It even gives us a box plot. Now, just to quickly go over box plot. This line represents, or feather as we call it, the lowest value. This line or feather represents the highest value. Lowest was 65, highest was 75. The bottom of this grayed out box represents the 25th percentile, and the top of it represents the 75th percentile, which means the difference between the bottom and the top is the interquartile range. 50% of the values, 50% of the subjects are in this range. The dark line across the middle represents the median, right? Just as a quick trick here, if the median were up here, that would say the middle value is closer to the top. That would kind of suggest that this is a skewed distribution. Being in the middle here suggests that it's more of a normal distribution, the median right in the middle. So, at any rate, now if you see stars or circles outside of this, it means that there are values that are so far from the median that SPSS suspects that they're outliers, and it may be data that you might want to re-examine and decide whether you want to use or not because it's so different than all the other data. In that case, the feathers would represent the lowest and highest values that SPSS thinks that you'll probably be working with in your analyses, right? Since this has no outliers, then this is just literally the lowest and highest values. Okay, so I'm gonna put this aside for a moment, and I'm gonna go on to the next problem. Okay. And let me find my way back here. Fox Pro. Okay, Firefox. Okay, so now question 9 asks you to open the NC Birth 800 file, the North Carolina birth file, and actually do some additional analyses on it. It asks you to complete the exercise that we started in class. Well, now the exercise that we started in class, there's a version of it that I put onto that I placed on Blackboard. Hang on a second. Let me see if I can't get back to my desktop here and find this. Let's see. Nope, that's not what I want. Nope, that's not what I want either. Where did I put that thing? Okay. Well, first of all, I'm going to open up. I gave you a couple of versions of this file. One is with the variables labeled, right? And one is with without the labeling of the variables. Let's see. I only show these, but there is a version that does not have the coding completed. So all you have is the numbers, but when you go to the variable view, it doesn't have the information about what the what gender means, what the 0 and 1 for gender mean for the child that was born, and so on and so forth. It doesn't have that information. You don't want to use that one. I only put that one in there as a demonstration of what it would look like if you have an uncoded file. So I'm going to open up this version. Now, in this version, what I asked you to do is a couple of things. Now, it opened up in the data view. Here is the plurality is the number of children at birth. Twins would be 2, sex of the child, mother's age, weeks of gestation, marital status, race of the mother, so on and so forth. Nominal variable, numerical variable, numerical variable, so on and so forth. If I go into variable view, you can see all these different variables are coded or labeled, and the values are actually in here. For instance, marital status: 1 is married, 2 is not married. Okay, it's already been coded for you. I'm going to go back to the data view. Okay, and I'm going to actually perform a typical analysis, what we were doing on the homework, for instance. Okay, so one of the things I asked you to do is go ahead, analyze this information, and find for the, say, birth weight. Let's say I'm going to change this up a little bit. Let's say we're interested in the age of the mother. Okay, so let's say descriptive statistics. Let's go into into descriptives, and I'm interested in the age of the mother. I'm going to click this numerical. And remember, descriptive statistics you would only do for numerical variables, such as age of the mother. Okay, so options. It's already I'm going to choose variance and range and so on and so forth. So if I run this analysis, I get a limited amount of information again. Right? I get the mean. Average age of the mother was 26, 27. Standard deviation, the variance, and so on and so forth, minimum, maximum. I get more information. I'm going to analyze, descriptive statistics, explore. And I know I'm going very fast here for those of you that are still there. Okay, well, let me make sure I mute everybody. I'm going very fast for those of you that are online, but I'm assuming that you'll be able to go back and watch this again later on and slow it down or stop it if you need to. So again, the age of the mother is going to go into the dependents list. And statistics, I just want to make sure it's going to do all the descriptive statistics, and I'm going to click OK. And it'll give me a lot more information about the age of the mother. Okay, if I had asked it to, it would also produce a box plot for me. The minimum age was 15. The maximum age was, looks like 42 or 43. Right, and here's our interquartile range. Here's our median. The median skewed a little bit to the bottom. It's pushed a little bit to the bottom, which means the average is probably above that, right? Because these high value, these older women are pulling the average up, right? So the mean is the average is being pulled away from the mean. So this is skewed positively. It's the direction that the mean is going that we say it's skewed. It would look like kind of like the tail is skewed out to the right. Okay, so and maybe we'll see that when we actually plot this data in the next segment here. So now, okay, so I've got a lot of information here, including a box plot. So I'm going to go back into Analyze. I'm going to go back into Descriptive Statistics. I'm going to go stick with Explore, except this time I'm going to say, well, let's see if there's a difference in the age of mothers that smoke versus age of mothers that don't smoke. Smoke is a nominal, categorical variable. I can put into the factors list a categorical or a nominal variable. I can't put a numerical variable in there. It won't make any sense. I can put in a categorical variable, like smoked during pregnancy. I'm going to move that in there. What's going to happen now is SPSS is going to say, I'm going to factor or break up the data into mothers that smoked and mothers that didn't smoke and analyze that data separately. This time, I'm going to go into plots, and I'm going to tell it, I want you to do histograms for these as well. Okay, so this is going to do histograms for these two groups. I'm going to split it up into two groups instead of one, like we did before, when there was nothing in the factor list. So this time, it will now. I'm going to click off stem and leaf. I don't think I need that right now. Let's say OK, and it's going to display both. And I'm going to click OK. Okay, and here we go. So the mean age of mothers who did not smoke during pregnancy was 27. The mean age of mothers who did smoke during pregnancy was 25. Maybe less mature mothers more likely to smoke, perhaps. Perhaps that's what that means. And our histogram. Here's our histogram for of the age of mothers who didn't smoke. Notice it does look like it's a little skewed to the right there, right? This is for mothers who did not smoke. This is for mothers who did smoke, right? And here we go. And these are side-by-side box plots, which show you where the middle value is and the range is for mothers of mothers that smoked, did not smoke, and for mothers that did smoke. Okay, and we can see the median value is lower for mothers who did smoke. The variability is a bit less in age, as it happens for mothers who smoke during pregnancy. We can see that because it's not so spread out. Okay, so at any rate, now what to do with this information now that we have it? One of the things that we're going to want to use this data somewhere other than SPSS. Not everyone's going to have SPSS and even be able to see this information. So we need to get this into a more universal form, such as a Word document or something that you can use to create a report. So one of the ways that you can do that is you can just simply select any chart. See, it's highlighted now. And you can say copy. And you can open a Word document. Now, it still is copied in there, I know. So I'm going to just say, go in here and say paste. Okay, so now it's pasted in. It is. You can actually go in here. You can highlight this, and you can make certain areas bold if you want to. You can actually edit this table if you want to. If you just say paste. If you had said instead paste special, edit. Oh, excuse me. Did I lose it? Yeah, I uncopied it. Hang on a second. Let me go back. Copy again. And I can go in here and I can say edit, and I can say paste special. Paste special will give you more options on how to paste it. Many of you, my version of SPSS, unfortunately, has a bug in it. It's the instructor version that they give out, and it will not. It doesn't show an option for a bitmap or a JPEG version, right? Right now, it's defaulting at formatted text. That's why you see the box and all the formatting there. I could paste it in as unformatted text, which is just the numbers and the letters, or style text and so on and so forth. That most of you will also see an option for pasting it in as a picture. If you paste it in as a picture, it'll look just like this, except that when you click on it, you won't be able to click into it and edit it. On the other hand, a picture is much easier to go in and resize and move around than this table is, right? So you have that option. You can paste it in as a picture, or you can paste it in as a table, depending on if you really need to edit it or not, or if you just want it to be more portable and easier to work with. Okay, so now you can also do the same thing with the histograms. You can click into this, you can say copy, and you can paste it in. Now watch this, I'm not going to be able to do it because I have a bug in my program. Right? Didn't come out, right? So just so you know, you guys that use a Mac, there's a program in your utilities. If you click on the desktop and you go to Go, you can go to utilities. There's a program in there called Grab. I've already moved it down to my menu bar here so I can get to it easy. This program called Grab, I can go in here and I can say capture a selection. And for those of you who have the same problem I do, and I can highlight the histogram. It captures that in a new file, right? That happens to be a TIFF file. I can say copy that, and I'm not sure if my version of Word likes TIFF files. We'll give it a try now. And then I can say, oops, I missed. Let's see, edit, say paste. Didn't like that either. You know, I think it's in my Word that's got the problem. Okay, actually what I can do is I can save this and convert it to a JPEG file. Let me see, save as. I'm going to save it to my desktop. And when I double click on it on my desktop, a little bit of work, right? I can say export to JPEG. This is in preview. You guys that have Macs will know what this is, right? And now it's a JPEG. Now I bet you this JPEG I can copy into my Word document. Let me give it a try. Where'd I put it? Here's a JPEG. I can copy it in here now, I'm pretty sure. Where'd it go? No, it should work. Let me get a new blank document here. Boy, it's really resisting what I want to do. Insert, and file, desktop. There it goes. Okay, I use the insert command in Word. Insert and photo or image file. From file, just navigate to the desktop where I had saved it. Let's see if it'll work with a TIFF file too. No, it didn't seem like a TIFF file. Did work for the, well, maybe because I had that still selected or replaced it. Insert, photo, picture from file. Shut file. Nope, it replaced it. Okay, well, at any rate, you know it'll work for JPEGs. Okay, and to tell you the truth, there probably is only one or two of you that have the same issue that I have. And I'm hoping I'll get rid of that issue when I change my version of SPSS and when mine expires in about 20 days or something like that. You know, I don't think it does. I think it's a problem of my version of you do have the option of copy special when you copy in SPSS, but I don't think that works any differently. So I'll have to, hopefully, maybe I'll figure this out by Monday. You know, maybe I'll talk to ICET, see if they have anybody else complaining about it with this version of SPSS. Like I said, I have to upgrade my version pretty soon anyway, because it's about to expire. So maybe when it's upgraded or patched, it'll work a little bit better. All right, so I don't think most of you guys are going to have this problem. But the whole point of this is that you need to put it into you need to get it in here in a form that it's actually useful, and that's best suited by pasting these things into Word. There's one other thing you can also do in SPSS with your output file, and that is we can say export. Okay, and we can export it as a Word document. Your output file is a Word document. In other words, as a RTF, a rich text file, or a Word document. Okay, I'm going to go ahead and do that. And let's see, it's going to go on in my documents folder. I actually want to put it on my desktop for now. I'm going to go back to my desktop. Okay, and I'm going to save the output.doc document to my desktop. Come on. Go ahead and save it. Oh, that's it. Waiting for me to give it a name. There we go. And now if I look on my desktop, it should be there. There's my output.doc file. Let's see what it cut pasted in. Oh, this version actually put in, you know, that's a good way around it. It actually transferred, if you saved it exported it as a .doc file, it copies it out into Word. I'll bet you from here you can copy and paste into other Word documents. Okay, so I think that's probably your best bet for getting around that problem. Would be to when you're in SPSS to say export, and then tell it to export it as a Word or RTF document, rich text file document. Okay, and that will export all of the different tables that you created. And from there, you can either copy them into other Word documents or just delete the ones you don't want and keep the ones that you want. Okay, so I think that's a good workaround. I think that's probably going to be the best workaround for now. For most, if you guys have any issues with that, that actually worked pretty well, and it's painless. Okay, so now that's basically what we wanted for question 9. We asked you to do that. So let's move on to homework number 2. Okay, no, I don't want to save that. Okay, I'm going to get rid of this. Now remember, the output files don't save unless you save them as separately from the data files. This okay, that's exit. No. Okay, and I'm going to get rid of this and clear up all this space up here so we can see what we're doing again. Okay, all right, let's go back to homework number 2. Let me exit this. Okay, where is my... Okay, let's go into assignment number 2. Okay, let me just make sure there's no questions. Okay, you guys doing okay in the background there? Okay, good. I think that's a good workaround for you guys that are on the Word that have problems copying and pasting. If you just export it from SPSS, the whole output window as a Word document, it's going to be a lot easier than individual. It might even be easy for a lot of people if you had to do number tables. Just save the whole thing as a Word document and then delete the parts that you don't need. Okay, I know about that. Let me just click X so I can continue working. Okay, so let's work on assignment number 2. Okay, so assignment number 2. The prevalence of diabetes in the population is 10%. You randomly select 3 individuals from that population. What's the probability all 3 are diabetic? Well, these are independent events, and as long as these people are not related, that they're really that it's really a random sample and it's really independent. Well, then you can say that it would be 0.1 times 0.1 times 0.1, which would be 0.001, or 1/10%. Most of the time, I'm going to ask you to answer this as a decimal fraction, 0.001. Prevalence of diabetes in the population is 10%. Randomly, what's the probability that none of the 3 are diabetic? Well, that would be 0.9 times 0.9 times 0.9, right? You'd put the answer in there. Okay, it's known that 60% of the population has completed high school. You take repeated samples of size 3 and find about 20% of the time all 3 subjects have graduated high school. Does this result suggest that your sample was random and independent? Anybody want to take a guess at that? What would be the expectation if 60% of the population has completed high school and you pick 3 people out at random? What would you think the result would be? What percentage of the people would you expect? What percentage of the time would you expect to get all 3 high school graduates? Right, 0.215. Thank you, Carol. About 22%. Well, in fact, when you do that over and over and over again, you find that the average result you get is indeed 22%. Okay, so that this result suggests, what does it reject? It suggests that your sample was random and independent, right? You've confirmed that it really is about 22%, the outcome if you test this population. Now, had it come out to 35%, that would have suggested that your sample was probably not independent, right? Maybe it wasn't, it could be not random, could be not independent. More likely it was not independent if you pretty much tried to make it random. So if you didn't get 22%, that would make you suspicious as to whether or not you really knew what the population prevalence was for graduating high school. Okay, so on these things, this one's B, right? The area around, excuse me, We get a sip of water. You get the frog out of my throat. Okay, so the area, if I, let me start with this one. This one would be, we know, is the union of A and B. So all of the values that are either A and B. As it happens, there's a bunch that are both A and B. In other words, this A might be people that are left-handed. B might be people that are taller than 6 feet. So there is a certain proportion of people here that overlap that are both left-handed and over 6 feet tall. So A union B would represent this particular Venn diagram, right? Now, let's say I wanted to know what's the area outside of this. Well, the area outside of this is people that are not left-handed and people that are not over 6 feet tall. That would be not A, union, not B, right? So it's the area that includes all the people that are not A and not B, or not B, interestingly enough. Okay, so this one's just B, right? All of the people that are B, over 6 feet. This one is A intersection B. Excuse me. That's A intersection B. In other words, that's all of the people that are both A and both B. In other words, both left-handed and over 6 feet tall. If I actually put numbers into these things, I could ask you, well, let's say that this is 100. There's 100 people that are left-handed. There's 100 people that are uh, 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 over 6 feet tall, and there's 20 people that are both. Well, that would tell you, gee, what, actually, I should phrase it another way. The area here that doesn't include the shaded area in A. In other words, A but not B, right? A but not B, right? This area that's not shaded here inside A, right? I might tell you that that's 80, right? And this area over here that's B but not A, I might tell you that that's 80 also. And I might tell you that the area in here is 20, right? So you would know that the total number of people that are A is the 80 plus the 20 that overlap, which would mean 100, and there'd be 100 people in B also. So you might be asked to kind of figure that out from the numbers I give you on the chart. Okay, but this is A intersection B. Okay, and what is this? Well, this is everybody that's in A but is not B, right? So this would be A intersection not B, right? So we don't want the people that's in there. We want only the people that are A or that are not B. Okay, so I'm going to move on from there. And there's any number of, what was question number 4? What was number 4? Answer number 4. I got that right. We got that. Right, number 4 was just B. Did I answer that question, Elma? Okay, good. Okay, and let's go to this. Okay, prevalence of a condition that was popular in high school when I was a kid is cooties is 10% of the population. Newly developed diagnostic test of 1,000 randomly selected subjects with the following results. Well, you can see that this agrees with the idea that the population that the prevalence is 10%, because out of the 1,000 people that were sampled, 100 of them actually had the disease. Right? Anybody in this column has the disease. Okay, so 100 people had the disease. Okay, so if I look at this, out of the 100 people that have the disease, right? How good was this test at identifying those people? Well, it identified them correctly 80 out of 100 times. Out of 100 people, 80 of them were tested and were positive. So it's 80. The sensitivity of this test is 80%. So in this population, 900 people did not have the disease. What happened to them? Well, what happened to them is that we wanted a negative test result because they don't have the disease. We got it 810 times. So how good was it at identifying people that don't have the disease? Well, it's going to be equal to 810 divided by 900, the number of people that don't have the disease, which is 90%. So the specificity of this test, how good it is at identifying people that don't have the disease, is 90%. Well, the next thing we might be interested in knowing is what is the positive predictive value of this test? If you get a positive test,
it's 11
how sure are we that you really have the disease? Well, let's see. People that are in this row all got a positive test. There were 170 people in this population who got a positive test. Only 80 actually had the disease. So how predictive is this test? Well, let's see. 80 over 170 is equal to 47% or 0.47 or 47%. So if you got a positive test, there's a 47% chance that you actually have the disease. The positive predictive value is 47%. The negative predictive value would be 830 people do not have the disease, 810 of them actually are negative. So it would be 810 over 830, which would be, I guess, about 97 or 98%. Okay, that would be the negative predictive value. And that's basically what we did throughout this question. Okay, so I'm going to go down here. The last question I asked you, well, we have a formula, we have Bayes' rule, which gives us information about predicting conditional probabilities. And in a sense, positive predictive value and negative predictive value are conditional probabilities. For instance, the probability of A given B. In this case, we're going to look at the positive predictive value. The probability of having the disease A given that you have tested positive B, right? Probability you tested positive is PB. Probability you have the disease is PA, right? Is equal to the sensitivity times the prevalence divided by the same thing, sensitivity times the prevalence, plus 1 minus the specificity times 1 minus the prevalence. So what does this mean? This means if I don't even give you these boxes, if I just give you the sensitivity, the prevalence, and the specificity, you can use this formula to calculate the positive predictive value, right? And what would that be here? That would be 0.8 times, what I said prevalence was here? 10%. 0.8 times 0.1 divided by 0.8 times 0.1 plus 1 minus 0.9, I forget what that was, 0.9, right? 1 minus 0.9, which is this whole thing turns out to be 0.1, times 1 minus the prevalence, which is 1 minus prevalence is 10%, 1 minus 0.1, that would be 0.1 times 0.9. So you work out this 0.1 times 0.9, add it to my 0.8 times 0.1, add those two together, that would be your denominator, and the sensitivity would be your 0.1 times, 0.8 times 0.1, right? So it'd be 0.08 on top, and then on the bottom here would be whatever that worked out to, and you should be able to. Isn't the prevalence 0.05? Would that change? Where did I say? Did I say? Oh, I'm sorry. You're absolutely right. I didn't read that. It's really small letters there, and I looked right past it. You're right. In the problem, I said make the assumption that it's a different population, same test. So the sensitivity and the specificity. It's the same test. They don't change. But now let's take a look at it in terms of population that has only a 5% prevalence. And in fact, we know the positive predictive value is going to go down if it's a lower prevalence, if the prevalence is lower. So you're absolutely right. I should have used 0.05 instead of 0.1 for the prevalence in all of these cases. And you would just simply work as a math problem from that point on.